from human to human, the ability to do the same task may be different. Okay, then right now, most companies are in the transition between IR 3.0 to IR 4.0. IR 4.0, perhaps later I will go into the definition. Okay. So a bit of history. Again, I know the talk is about challenges, but it's better if I go through all of this first. Okay. Actually, IR 4.0, although the word Industrial Revolution 4.0 is a common term, but each country over the years have come up with their own terms to suit their own customs or their own production behavior, depending on the country. Of course, IR 4.0 was introduced by Germany, and it promised to bring remarkable benefits to the manufacturing industry worldwide. After Germany introduced IR 4.0, this is when US introduced smart manufacturing. I think most of you would probably have heard this term before. Smart manufacturing is, remember IR 3.0 is about automation. So IR 4.0 in US, they call it smart manufacturing, but basically it means the same thing. You want to integrate different components of manufacturing. At the same time, China also revealed a national 10-year vision, Made in China 2025. The goal of this is to make China a hub for manufacturing. That's why you see, if you purchase many goods online, you realize that most of these goods are manufactured in China. So they are on their way there to make sure that they have, by 2025, China is a manufacturing hub of the world. Besides that, Japan has also shared the vision of Society 5.0. Okay, you see that this one is 5.0, but industrial-wise, it's Industry 4.0. This is because Society 5.0 focus on the digitalization of life sectors only. Right now, Industry 4.0 focuses more on manufacturing. Society 5.0 focuses on retail, focuses on food industry, different types of industry. And also Saudi Arabia launched a Vision 2030 because Middle Eastern countries like Saudi Arabia are rich in natural resources. In order to take advantage of their natural resources, before they are able to process all of their resources in-house, they realize that they've been wasting a lot of resources by outsourcing it to different countries. So their goal is to move everything in-house, make sure it's aligned with latest innovation. Okay, so this is just a bit of history. Okay, so this is a formal definition for IR 4.0. Okay, so I'll just go through this. You don't really have to know this, but just focus on the keywords highlighted in bold. Okay, so Industry 4.0 revolves around creating a smart manufacturing environment through interconnecting smart production entities, okay, such as smart products, movable and stationary machines, tools, robots, storage and retrieval systems, material handling, and other production entities by utilizing powerful features of latest advancements in ICT and CPS. Okay, a real-time data capturing system such as RFID, sensors, digital cameras is utilized to control the production and react to any incidents or situations through complex and elaborated algorithms that control the interaction. So you see, the first point talks about integrating the elements using ICT and CPS. Right now, most factories are operating in the transition between IR 3.0 and IR 4.0. They have all these elements such as smart products, movable and stationary machines, ASRS systems, material handling systems, but all of them are not integrated. They are not interconnected. Okay. For the second point, a real-time data capturing system. Most companies already have real-time data capturing system, but they don't have the feedback loop. The loop is utilization of that capturing system to control the production process and react to it. Right now, the control mechanism in most factories is not reactive. Okay, so this is the definition. Okay, so what is the purpose most industries intend to transform to IR 4.0? The first one is to gain competitive advantage. Okay, so because most industries and governments are talking about IR 4.0, more people are doing it. There comes a point where each company, their customer base, will want to select a supplier that hosts IR 4.0 in their manufacturing. So that is why people are using this as a niche to market their product. Okay. The second one is to become a low-cost supplier. If you go back to the definition earlier, you will see that that second point, and react to any incidents. Every time you make decisions reactively, instead of you taking your time, what happens is your lead time for manufacturing decreases. Every time the lead time decreases, the cost per unit for manufacturing also decreases. That is why IR 4.0 promises a manufacturing plant to become a low-cost supplier. Okay? Because of this advantage that you can take, because of this advantage of the ability to having low cost per unit in manufacturing, manufacturing companies are able to develop differentiated, innovative products and services. You see, because due to the shorter lead time, they can customize product according to the needs of their customer. Okay, because the downtime for transition is not that long. Also, they are able to target a niche geography. Because of this customization, they can target customers from different geography, different industry, and different industries. Okay. Okay. So the whole point of IR 4.0 is a faster response to change in technical requirements. As mentioned earlier, the whole point of this is to reduce the lead time. Okay. Okay. So again, we are getting there. The next slide is almost about challenges in IR 4.0, but this slide is like, can give you an idea what are the challenges that could arise. So you have 3 columns here. The first column is technical competencies that every industry must have in order to be able to adapt IR 4.0. The second column is should, which means it's good if they have it, but even if they don't have it, it's not a problem. Could is, it's better if you have it. Okay. Of course, industries who wants to sustain IR 4.0 in their manufacturing plant, it's good to have all 3. Okay. Perhaps that is in the near future. But for now, most industries are tackling column 1 and column 2. Okay. So in column 1, what we have is IT knowledge, data processing, statistical knowledge, organizational understanding, and interaction with modern interfaces. So I think in this case, most of us have, I think most universities do cover these elements, okay, in whichever course you study, okay, be it engineering or business. You have some form or some of these courses. In terms of the second column, knowledge management, knowledge about technologies and organizations, awareness for IT security, and specialized knowledge of manufacturing activities. So this column, you can see that not all courses cover this. It's starting to get more specific. For example, knowledge about manufacturing activities is covered mostly in manufacturing engineering courses. Knowledge for IT security and data protection is covered mostly in computer science. Okay, so it's starting to get more specific now. And when we go to the third column, computer programming, specialized technologies, ergonomics, and legal affairs, this is very specific. It's almost appearing like it's an elective course, okay? Not everybody who graduate has knowledge about this, but in order to sustain IR 4.0 in an industry, it's important also to have these elements, okay? Perhaps most of you are engineering students, so I think most of you are familiar with the term ergonomics, okay? Nowadays, if you see most of the car designs, you will notice that some designs are not very ergonomic, okay? It doesn't take into account the type of passengers that could sit in the car. People of different ages have different abilities. Some people from the older generation have joint pain. So if the seat is built a little too low, it's catering more for the younger generation, not for the older generation, things like this. So you see, even small things like this is important in IR 4.0. Okay, so, okay. Now this is the social competencies. There's only 2 columns here, and this is quite self-explanatory. We have self-time management, ability to adaptable to change, teamwork, social skills, communication skills. Also, ability, continuous improvement, and trusting in new technologies. Okay. Okay, so based on these 2 new tables, we have come to the first challenge of IR 4.0. So the first challenge of IR 4.0 is the demand for highly skilled engineers that can contribute to IR 4.0 not met because existing engineering curriculum is not all integrated with IR 4.0 elements. I use the word existing engineering curriculum because I myself am teaching in the engineering department, and I understand when I go to industry to meet with engineers, when I consult them about their production, they do tell me that off late, their graduates have some skills lacking. This doesn't mean that the graduates are unable to learn. It just means they are not well equipped before they start the work. Of course, once they start the work and then they're able to learn, they are already equipped. But it would be better if the engineering curriculum, or perhaps any curriculum in the university, is equipped with elements such as IoT, cloud computing, CPS, big data, autonomous robots, simulation, horizontal and vertical integration, additive manufacturing, augmented reality, and blockchain. Okay, so from all these keywords here, I understand I'm speaking to engineering students, so I'm sure all of you can identify with only some instead of all these keywords, because only some of this is addressed in our syllabus. But if you remember the definition for IR 4.0 in the earlier slide, all these keywords are already there. Okay? So because of this, because not all of these elements are addressed in our syllabus, it is also affecting the way our design projects, our final year projects, and our assignments are carried out. Okay. Design projects and final year projects in most universities are carried out in the final semester. So you see, because all of these fundamental theories are not covered within the year 1, year 2, or year 3 of the syllabus, by the time you want to begin a design project, all of our design projects or our final year projects revolve around existing elements that we've covered in our engineering. There's no projects that is related to big data. There's no projects related to augmented reality or blockchain, specific, for example, my field, industrial engineering. So by the time these graduates, they go out to work, if the industry requires them to have some knowledge about IR 4.0, perhaps they can get a job by informing their employer that they have somewhat knowledge about IoT or cloud computing or simulation, and perhaps additive manufacturing. But for the remaining ones, it does not cover, is not covered in existing engineering syllabus. So that is why most universities are trying to adapt to this, trying to include more of these elements into existing syllabus. Perhaps not a full course, perhaps certain topics in existing courses. Okay, so this is the first challenge. The second challenge is constraint faced by SMEs. Okay, so this word SME is small, medium enterprise. Perhaps we go to the definition first of what exactly is an SME. Remember, we have two branches. We have MNCs, multinational companies, and SMEs, small and medium enterprise. So small companies are sales turnover with less than 300 ringgit. I'm explaining this in the context of Malaysia. Okay, perhaps in Indonesia, it's slightly different. The range of turnover or the number of employees, but the breakup among small, medium, and micro is obviously still there. Okay, so for small, it's 300 ringgit to less than 15 million, or full-time employees from 5 to 75. For medium, it's from 15 million to less than 50 million, 75 to 200 employees, and micro is 300 or less than 300,000 or less than 5 employees. Okay, so most SMEs face this challenge because SMEs, industrial automation transformation are impeded by factors such as financial constraints attributed to expensive software and hardware. The thing is, most SMEs operate on the basis of a very small customer base. Even if they have customer base from overseas, their customer base are not very wide. So because of that, most of these industries or SMEs still operate on the basis of IR 3.0. There is definitely automation. I think most factories in Malaysia don't operate on IR 4.0, 1.0 and 2.0 anymore. It's 3.0 and above. But most people remain as 3.0 because of the financial constraints. You see, what type of constraints do you face? The first one is the software and of course the hardware. If you remember the definition of IR 4.0 in the earlier slide, require two elements to integrate them together, which is ICT and CPS. Okay, cyber physical system and ICT. So in order for SMEs to upgrade their manufacturing process to IR 4.0, it requires training of manpower to accommodate their upgrade. Okay, of course, another question that arises for SMEs is the turnover. Because most SMEs operate and they have an understanding that manpower in SMEs are not permanent. So what happens if, for example, they train one particular staff on upgrading from IR 3.0 to IR 4.0, but halfway through the transformation of the facility, that person leaves. So who is going to carry out the following work? So this is another problem that they have to figure out. Okay, and then another one is, of course, governments in many countries do provide loans and tax incentives to help SME. But the thing is, even with loans and tax incentives, there needs to be a consistent guidance for all these implementers on how to acquire this funding. You see, most SMEs have very little knowledge about where to obtain funding from. So that is another constraint, where to obtain funding. Okay, so you see, because of some of these constraints, most SMEs with the intention to upgrade to IR 4.0 proceed to one of these two routes. The first one is, we understand that transformation from IR 3.0 to IR 4.0 requires continuous funding. It's not one-off funding. So that is why when they request for funding, they have to project the cost, the technical competence. Hello? Hello? Sorry, I can't hear you. Can I continue?
Please proceed.
Oh, okay.
Please.
Okay. Okay, so where was I? Okay, so because of this constraint faced by most SMEs, they have two options. The first option is to consider continuous funding. That means because the transformation from IR 3.0 to IR 4.0 is not one off, but it proceeds in several stages, they have to project their costs, the technical competency, and their funding required throughout that stages. So that way, they don't have to keep requesting for funding from the government. So this is one of the constraints because the projection of how much cost they would require in the future cannot be foreseen. Again, in order to foresee these challenges, we need someone with knowledge in IR 4.0. But in the first place, we require someone with training. So you see, they fall back on the same, you go forward 10 steps, you go back 11 steps every time SMEs want to implement this. So because of this, most SMEs, if they don't go for the first route, they go for the second route. They will discard the idea of upgrading to IR 4.0, but they may also consider to upgrade in smaller stages. The reason they choose smaller stages is because, again, to gain competitive advantage, some of their customers will require industries to have some form of IR 4.0 elements in their manufacturing. So they selectively implement certain IR 4.0 elements in their manufacturing, not entirely, but few of it. Okay, so these are the two challenges. First one is existing curriculum in universities do not cover the elements of IR 4.0. Second one is funding to upgrade existing SMEs from IR 3.0 to IR 4.0. Okay, so after we know these two main challenges, the question is how are we going to embrace these changes? So this is a figure that is obtained from Veza et al. 2015. You can see from this figure, we have three elements here: government, industry, and university. The previous two problems cannot be solved. For example, when we talk about upgrading existing syllabus in universities, the university alone cannot solve this. If we want to upgrade funding for SMEs, the government alone cannot solve this. There needs to be input from all three, okay, from the government, university, and industry. That's why we have the three boxes on the left, which is the contribution between university and government, on the right, between the government and the university, and the bottom, between university and industry. Okay, so let's go through this one by one. The first one, between government and industry, the government is good if the government encourage collaboration with industry because they have real life projects and lifelong learning elements that can be learned from the industry. And because of this, there will be a transfer of latest scientific research to the industry. Okay, so on the right-hand side, the government, once they have acquired, once there is technology transfer or knowledge transfer between the industry and government, the government can then transform this to the university. Okay, because a university have sufficient manpower, so the university is able to encourage spin-off and startup enterprises. Then at the bottom, between industry and universities, I think most universities now already have this thing called an industrial advisor panel, which means that existing engineering courses do receive input from stakeholders from the industry. Okay, because there needs to be a balance between engineering science and engineering practice. So their input will serve as a platform to include any new curriculum or study programs into our courses. Okay, so I think that is all for my presentation. Thank you. These are my reference. So that's all for me. Maybe I'll stop sharing now.
Okay.
Is there any questions from anyone?
We can put the question in the Q&A session, yeah, Dr. Joshua.
Okay.
We proceed to the second presenter. Dr. Tony, is there any? Yes. Okay, good. The screen is yours.
Okay.
Thank you.
All right. Okay, thank you. Good afternoon, everyone. Thank you, Pak Taufik. All right. So, yeah, very good afternoon to students and staff of BINUS and to the other guest speaker as well. Really wonderful to be here to share with you some insights on Industry 4.0, especially how it is relevant to your course of study, I think, and also to give you a glimpse of how is I 4.0 taking place in Singapore. Okay, so yeah, so myself, my name is Tony, and I'm from Temasek Polytechnic. Okay, so let me go slide. Okay, yeah. So this is my cover. Okay. So yeah, so any questions that you might have, you can post onto the chat box, or later, probably at the end of the session, there's a discussion segment and we can go into that, okay? All right, so yeah, so my name is Tony. As you can guess from my surname, yes, I was originally from Indonesia as well. I won't tell you where I'm from, but I think you can guess which part of Indonesia I came from. Maybe you can make a guess. And let's see if we have time later, I can answer you, all right? Okay, so these are the agenda that I'll be covering. So first of all, let me give an overview about what exactly is industrial engineering, because I believe most of you will be are students who are undertaking the industrial engineering program with BINUS. Yeah, so in a nutshell, let me just quickly run through this. I believe your lecturers are the experts in this area, and throughout your journey with BINUS, you will learn even more details about what industrial engineering is all about and why it is a very useful subject, okay, or rather a useful discipline. I understand there has been some introduction about myself already, but again, just a very short background. I was originally trained as an electrical engineer. Then when I convert and do my master's, I moved on to industrial engineering. But at that time, my industrial engineering during my master's was focusing more on quality and reliability. So that was my my master's. Then for my PhD, I moved on into industrial engineering, but onto some other branch, which is more related to the supply chain management. Because industrial engineering is a very wide field, covering almost everything and anything, okay? So end of the day, what is industrial engineering all about? It is a subject matter that concerns the design and improvement of systems. And it's not just, we are not looking at just people, machine by itself, but we're looking at how can we integrate all these systems in a more efficient way and to bring about improvement in productivity. So it draws upon basic skills, your mathematics, your science, your statistical skill, your analytical skills, and you also need to know a little bit about the social sciences, all right, in order to do a good job in this IE area. So for industrial engineering, this is the standard body of knowledge from the IISE. I will not go through this in details. This can be easily searched from the internet. As you can see, it covers many things, from design of the workplace, from facilities management, from quality and reliability, from operation management, supply chain management, ergonomics and human factors, design, manufacturing, system design, so many different areas. So if you are trained in this area, I believe you will not be out of job, right? Because there are so many industry segments that you can plug yourself in, because regardless of which industry, they are always looking for ways and means to reduce costs and ways and means to improve productivity. And that is what industrial engineering is all about, improving the productivity, okay? So that is in a nutshell what IE is all about, right? So now that we understand what is IE, let's now move on to what is I 4.0, right? Which I believe you have heard about it. I 4.0 is nothing new. It started out because it's version 4, definitely there's some early on version 1, version 2, and 3. So this is just a very simple schematic to show you how the Industrial Revolution has started since then. So it all started with when people invented or discovered the steam power, and they realized that, oh, with steam power, things can be moved, you can move heavy machineries and so on. So productivity improved, because in the past, probably they used animals, they use human, but now they can replace it with machines, and things move on very fast. And that's when things happen, and you move on to 2.0. That's where your circuitry comes in, electrical energy comes in, and then move on to 3.0, and that's where your computers start to come in. 1969, but of course, at that time, when we talk about computer, it's nothing close resemblance to the laptop or iPad that you're looking at. At that time, the computers is big, is huge, like a cupboard like that, like a wardrobe, okay? And at that time, they are talking about megabyte. Unlike our time, we are talking about gigabyte or terabyte already. So it's a different era, but at that time, it was a revolutionary situation. So that's Industry 3.0. And now, moving forward, as things are in technology are improving in a exponential growth. And here we are in 4.0, and I believe soon it will be 5.0, right? So what exactly is 4.0? 4.0 is where you integrate the capability of the internet, the capability of computing power together with the machines, and it helps to further improve the productivity. People can work remotely. We talk about the 4G, 5G, your internet speed now, even China is looking into the 6G already, right? So that is how the Industry 4.0 has evolved from many, many years ago, okay? Yeah. So like what the earlier speaker just now has mentioned about the Internet of Things and what Industry 4.0 is all about. Okay, so here are just some very wordy sites about what exactly is Industry 4.0 in case you did not catch what I've mentioned earlier on. As you can see, Industry 4.0, the whole idea started out from manufacturing. Manufacturing is still a very important sector, especially in ASEAN context. I believe in Indonesia, manufacturing is a major contributor to the GDP. Likewise, manufacturing is also an important industry segment for Singapore as well, which I think we talk about China, Vietnam, Thailand, ASEAN, manufacturing is a very important area, right? And that is where Industry 4.0 has the largest impact in terms of improving the distribution, the production, and help to bring the cost down. And that's how a company can stay competitive, all right? So manufacturers are using new technologies like Internet of Things, cloud computing, analytics, even AI into learning the production facilities and so on, right? So it helps to improve the operations. And end of the day, with AI and past data, we talk about big data and so on, so it helps to bring about better decision making. Maybe in the past, before 4.0, maybe when it's 3.0, people are making decision probably by simple analysis, like looking at past trend and then doing some expert opinion, expert guessing. But now with AI, before you even run your operation, you can even simulate it, okay? So if now I switch this machine to that machine, I move around the layout of the factory, how will it be like? How will it improve the productivity? In the past, you may really need to do a prototype and really do a small scale setup to see whether things improve or not. But now with computing power, Internet of Things, you just need to simulate. Everything can be done on a computer, build up your factory on a virtual platform, and then you just simulate it and see whether the throughput has improved or not, whether your production, your cycle time has reduced or not. So things can be done virtually and simulated before you do it on the actual factory floor itself. And all this help to bring down the cost, right? Because you minimize unnecessary try and error, because if you do it on the machine, it's almost like free, right? So that is what the power on and the beauty of about what Industry 4.0 is all about, okay? So why exactly is Industry 4.0 important? Because as I said, it helps to save time, money, help you to make business decision. And nowadays, we live in a VUCA environment. things are very competitive, things are moving very fast, technology change very frequently. I believe you change your phone much more frequently than your mom or your dad, or even much more frequently than your grandparents if they're still around, right? In the past, a phone can last them 3 years, 4 years. But nowadays, you look at our smartphone, every few months, a new model come out. Every few months, another model come out, right? So things are changing very rapidly. So how can we do a forecast? How can we adapt to the new consumer behavior and trend? And that's where Industry 4.0 comes in. It helps to make your manufacturing, decision-making more nimble, right? And really, you can be anywhere and everywhere to operate your machines and so on. So I believe during the COVID situation, you have watched some video clip where in China, some of the workers, they can even operate the crane, operate the vehicle virtually. They can be at home with a huge panel and they just operate the crane, and a physical crane or machine is somewhere hundreds of kilometers away, really operating on sites. And all these are enabled by the Internet of Things, cloud computing, and very fast speed of the data communication, 5G, 6G, and so on, right? Yeah, so that is the thing about Industry 4.0, okay? Now, maybe it's good for me to share with you some video clips before I move on to the next slides. Okay, let me now bring on to the form. Let me share some video clips. Okay, so this video clip that I'm sharing is about one area in Singapore. We call it the Jurong Innovation District. If you are familiar with how Singapore is being structured, Jurong is on the west side of Singapore. Our airport is on the east side of Singapore. Changi Airport is on the east side. Okay, so Jurong is all the way at the west side. It's near to NTU. Yeah, near to NTU. Okay, so let me share this clip with you. It's about how they are making that area a 4.0, I4.0 hub. Okay, enjoy the short video clip.
Manufacturing is entering a new age. An age of endless opportunities for the knowledge industry. Singapore is taking the next big step in developing its advanced manufacturing ecosystem.
Jurong Innovation District will be Asia's leading one-stop advanced manufacturing hub. Wholly master planned, developed and managed by JTC. This district supports our Manufacturing 2030 plan, representing the next lap of manufacturing in Singapore. When fully completed, JID will nurture an ecosystem of technology providers, high-tech manufacturers, researchers, and educational and training institutions. This is where technology, talent, and sustainable design converge to inspire ideas and accelerate solutions.
We've created a living lab environment designed to open up new opportunities, whether you're looking for a testbed for experimentation or partners to develop 5G and artificial intelligence technologies with. JID has it all.
Hyundai Motor Group Innovation Center in Singapore will be an open innovation lab focused on future mobility research. Jurong Innovation District has the right mix of advanced manufacturers, academic institutions, technology providers, and services.
By locating Makino's Additive Manufacturing Center of Excellence in JID, we hope to foster partnerships with more industry partners and institutions.
Key of the Advanced Manufacturing Transformation Center is to accelerate the adoption of the existing and upcoming factories for additive manufacturing. We set up there a complete ecosystem that is accessible to all companies embarking on their digital transformation journey.
Jurong Innovation District has a really big potential and also big advantage. For us at Bosch, it's so important to develop our ecosystem approach, bringing academia, smart industries, smart people together within the Bosch Rexroth plants and also in our facilities.
At its core are people, those who determine your success in your advanced manufacturing journey. Our universities work closely with manufacturers to ensure that thousands of young creative minds are plugged into this ecosystem.
A campus is where one finds deep investigation of ideas. It is not merely a physical space, but rather a community developing and growing together.
JID is growing an advanced manufacturing ecosystem and bringing it right to your doorstep. All you have to do is plug and play. The possibilities, they're endless.
Your voice still mute, Doctor.
Yeah, okay. So I hope that is a good insights into what Singapore is doing, pumping a lot of investment to build up this area, so that end of the day, why are we doing that? Because we want to attract MNCs over. When companies come over to set up their factory, of course, it creates high value jobs. It's a win-win situation. Okay. Yeah. So I believe every country are also pumping a lot of money to this particular area, right? Okay. So if we were to connect the dot, how I mentioned about industrial engineering, I mentioned about Industry 4.0. So these two seems two separate things, but actually they are very intertwined to each other, right? Because end of the day, we are all concerned about improving productivity, i.e. your main outcome, learning outcome is to help the company improve productivity. Industry 4.0, end of the day, is to help the company improve productivity also. So now do you see how industrial engineering and I 4.0 is very much, they are very much intertwined together to serve the same objective, all right? Okay, so yeah, so I already shared about the manufacturing segment itself in Singapore. So you from the video, you see the emphasis is they want to attract manufacturers, all right? Yeah, so it's an ecosystem by itself where it is not just having the cloud computing, the infrastructure available over there. End of the day, we also need to ensure the connectivity to the port, the transportation is also seamless, because Singapore port is very well connected to the other parts of the world. So that's where they add value to each other. The JID and the Singapore port together, it helps to Singapore to be like a global exporter, right? Yeah, so it's an ecosystem of things. So you cannot optimize one area by ignoring the rest. You need to optimize the whole segment, right? Okay. Yeah, so this is just to share with you how the different region are developing the Industry 4.0. So I'm not too exactly confirm whether the years are correct for other country, but at least let's say for Singapore, the whole journey started from 2014, where the government are paying more attention towards Industry 4.0 and so on. And if you look all the way at the right-hand side, the tagline for Indonesia then in 2018 by the government was making Indonesia 4.0. Okay? And then so they launched the IR 4.0 in this field sector. Okay, so maybe moving on 5 years later, there could be some fine-tuning on this segment that we are looking at. All right. So yeah. So what exactly is this Industry 4.0? Right. So these are the key things which by now we have been hearing back repeatedly, like IoT, AI, 3D printing, and so on. Right? So there's no escape from having advanced robotics. There's no escape from having wearable AR, VR. But wearable AR, VR will work only when your communication is high speed. All right, because you are wearing your gear, but you are operating an equipment hundreds of miles away. Right. So maybe now is also a good time for me to share with you another short video clip. Okay, this video clip is a news on our local news channel, News Asia. This is about our latest research facilities in Temasek Poly itself. We call it the Advanced Manufacturing Center, right? So let me just play this short video clip. And main thing is I want to show you what is inside the latest facilities that we have.
$7 million center in Temasek Polytechnic focusing on advanced manufacturing technologies. Education Minister Chan Chun Sing says similar training centers for other fields will be built across the island to inspire and equip students and workers alike to seize new opportunities.
Business school student Rebecca Wee is learning about augmented reality here as part of a diploma in logistics and operations management.
With the headset on, I'll be able to connect with the operator via my phone, and they are able to actually find out what's the problem about the system, so they don't have to physically be here.
It's hoped that students like her will distinguish Singapore as a key manufacturing node.
We talk about attracting quality investment. We talk about leveling up our SMEs' capabilities as an ecosystem. But ultimately, the third and most important point is this: our ability to train the next generation of workers that can embrace all the technologies that we spoke about. Internet of Things, robotics, and so forth.
The center will train about 2,500 people per year and help small and medium-sized firms innovate. This as countries race to open up amid the COVID-19 pandemic and attract investments.
As we continue to up the vaccination rate, as we continue to implement a suite of new safe management measures, we will have greater confidence to run faster in the way we open up our economy safely.
Industry partners have been brought in to keep the facility relevant to the sector.
Okay, so that is our Advanced Manufacturing Center. As you can see from the video clip itself, that's where you see the students are wearing the gear, the AR, VR gear, and you can see some of the machineries at work over there. Okay, so I do welcome students from BINUS to come over to Singapore and TP to visit us. Just contact your lecturers, and I'm sure they can plan the study trip to Singapore. All right, and as part of the trip to Singapore, most welcome to visit TP as well. Okay, all right, so those are the key technologies when we talk about Industry 4.0. Okay, so now the next segment, of course, the most important segment will be what are the challenges. So to build on to the first speaker on the challenges, so here I'm going to offer you a very macro view of the key challenges in this Industry 4.0. So of course, as you can see earlier on in all my sharing, Industry 4.0 is basically very much rely on digital technology, rely on computing, rely on internet. And hence, because of this reliance on Internet of Things, reliance on the cloud systems, reliance on the communications, basically you are relying a lot on the virtual world as well. One key challenge facing you are embarking yourself in this Industry 4.0, the key challenge is, of course, cybersecurity, because you never know who is looking around, looking at what you are looking at, who is accessing your database, looking at your recipe for your new technology, your latest R&D. You never know about that, right? So that's where this is usually a key challenge when we talk about cybersecurity. Right? So it's the same analogy as you can build a very beautiful house, but if your gate, your door is not well secured, you can imagine what will happen, right? So cybersecurity is an important area if we talk about Industry 4.0, because this is like keeping everything safe, because you are talking about probably billions of dollars of investment that could be gone in a blink, okay? Or it could be a situation where some other competitor might sabotage your operation by deleting your key files, or I don't know. There are so many things they can do with hacking your system, mess up your operations, and so on. Okay, so cybersecurity is something that I thought is one of the key challenges that's facing this segment of Industry 4.0. And why is it a challenge? Because to ensure, you know, sometimes, like as I said just now, you have a very beautiful house, then you buy a door, a gate, and gate can come in different form, right? You can have very solid steel gate, you can have wooden door. It really depends, and the cost does vary. All right. So of course, a highly secured door or gate is of course much more expensive than a cheaper material, right? So the same thing, cybersecurity. If manufacturer or owners of businesses don't see cybersecurity as something very important, and they just invest the bare minimum by just buying something off the shelf and they think that's good enough, sad to say that will not be good enough, right? Because it's what we call penny wise, pound foolish, right? So you save that little bit, but end of the day, you are exposing your businesses to such a high risk from hacking, from theft of key information, and so on. So the adoption on this cybersecurity is something that is still quite low in the ASEAN sector. Okay, so as I said, you look at on the right hand side, the last 3 points. One, of course, could be the lack of the IT infrastructure. Another one could be the skilled workforce. It's also one key point for maybe, I don't know, maybe it's an Asian thing. It's always the money, right? So when the bosses talk about money, main thing is they want to see how this money can translate to revenue, but they don't look at how the investment can help to protect your asset. So the mindset is also very different between Asian bosses versus people from the Western part of the world, right? So budget constraint. Okay, so that is on the cybersecurity, one key challenge, right? So how much you have to pump in to this to beef up your cybersecurity. Then, of course, the other key challenge, of course, is the people. Now, when we talk about Industry 4.0, definitely there's a fear among people that, oh, will they be replaced by machine? Will they be no more jobs, right? Because they are looking at how, nowadays, if you look at some of the videos, right, even now in China, they have driverless car already. You know, you call a taxi using an app. When the taxi comes, you'll be surprised that there's no driver at all. You just bought the taxi, the cab, and the taxi will bring you wherever is your destination. So this is what Industry 4.0 is all about. It's all the very high-speed communication. They can, somewhere in the HQ, someone will be tracking your car to ensure the safety. Inside the car, there also camera to ensure safety. So it's happening already, okay? Now, but the question is, will human be replaced, right? Will human be replaced? Now, if you look back, when the Industry 4.0 started, when machines start to replace human, right? Machines start to replace animal, replace human. Do people go out of job? No, because with every new technologies, it will also open up new doors for people to learn new skills and to the new jobs will be created. So with machines coming in to replace human, yes, they will replace the human doing the job, but the machines also need people to maintain. So that creates a new set of employment opportunities, right? So fast forward to now, Industry 4.0, I talk about the driverless car. Yes, now maybe we do not need a driver, but does it mean that the driver will be jobless? Not necessarily, because we still need people to know how to do the programming. We still need people to know how to repair the car. We still need to know, we still need to have people, warm body at the HQ to monitor, okay? So what this means is mindset of the people must be willing to change and willing to take up the new challenges, pick up new skills, and we have to adopt to the new ways of things, okay? And that's where institutions like BINUS, all the other universities are very important, where they come in, give new training to students, equip them with the latest skills so that they are all well equipped and be able to contribute to the industry, all right? And as student, one thing that I can share with you is your learning do not stop after you get your degree, because it's what we call lifelong learning. So after your degree, down the road, as I said, technology, they are evolving at an exponential rate. what you have learned in your university, 5 years later, I can guarantee 50% of it will be obsolete because new technologies come in, new ways, new method, it will be obsolete. What can you do with it? No problem. Your universities are there. There are other universities. There are many places where you can go back to BINUS again to further upgrade your skills by attending short courses, training, and so on. Yeah. So I believe your lecturers are also very much in touch with the industry, and that's how a university grow, right? By bringing in new technologies, new industry knowledge into the curriculum, and teach the students and send you for internship, send you to overseas trip to have a look at the companies and the industry. Okay. Yeah. So in terms of skill sets that we think are necessary to make yourself relevant to this industry 4.0 is that, of course, you need to have media and coding skill. This is necessary, definitely. Analytical skills, creative thinking out of the box. This is also necessary. Your ability to communicate is definitely necessary because now the world is so well connected. Like, for example, you know Grab, right? Grab. If I were to ask you, Grab belong to which country? Well, although the HQ is in Singapore, but Grab operates everywhere. And if you were to go to Grab, the help desk, it could be someone who is in Philippines supporting you, your query. So global mindset is very important. You need to be able to work as a team, right? And cross-cultural collaboration is something that is a necessity now, okay? Yeah, so again, that is the reason why we are here for this webinar, right? We have speakers from Malaysia, speakers like me from Singapore over here, sharing with you the insights of what is happening in our country, okay? So we are living in a very well-connected environment, so your communication skills, cross-culture is very important, okay? So don't ignore this area. Then, of course, your personal skills is something necessary. You need to be able to work under pressure, be resilient, and always be willing to learn. So nowadays, we are always talking about lifelong learning. So my best advice to you is never stop learning. Even though you will graduate from your universities years later, never stop learning. All right, always pick up new skills, going back to school to top up your skills again. All right. Okay, so yeah, so with that, I have come to the end of my very simple sharing. I hope you have learned a thing or two about what's happening in Singapore, what's happening in the ASEAN, and why your study is relevant to this Industry 4.0. Okay, thank you very much.
Thank you very much, Dr. Tony. Thank you for that exciting and excellent presentation.
You're most welcome.
Let's have a big applause to Dr. Tony Joshua. If you have any question for Dr. Tony, yeah, that please write your question to the chat box. Okay. I have.
Yeah. Let me read through the chat box.
Yes, some 7 questions. Okay, the first question came from the Mr. Henricus Bambang Triantono. What factors are related to the various challenges in AI implementation for Industry 4.0 craftsmen in Indonesia? Okay, Dr. Tony, can you hear me?
Sorry, what is the question? Because I see there are so many questions.
Yes, above.
Yeah. Okay.
From Mr. Henricus Bambang Triantono.
Okay.
What factors are related to the various challenges in AI implementation for Industry 4.0?
In AI implementation industry. Okay. My apologies. I'm not familiar with what is Industry 4.0 craftsman. Is it some program in Indonesia?
I'm not sure. Maybe Mr. Henricus can unmute and explain a bit. Any?
Yeah. Hello.
Yes.
Yes.
Hi.
Hello.
Yeah.
Maybe you want to explain about this factor to handicap in implementation artificial intelligence as practice.
Okay. Okay, maybe I try to answer this in a more general and generic way, not just for Indonesia. As far as I can see, AI is something that is still evolving because now there are so many different platforms. There isn't like a conversion to a standard yet. So I believe the challenge over here is there are, even within AI, you are talking about regenerative AI and different kind of version of AI. So there's so many things in AI for you to learn and to implement in your necessary trade. Okay, so over here, I see the challenge here is there is no so-called industry standard yet. Yeah. So like, for example, I give you an analogy. For example, if you are industrial engineering, I'm very sure you know about Six Sigma. Six Sigma is very well established, right? So exactly the same thing for AI. Is there a standard framework for AI? There isn't currently, because it's still something very revolutionary. Okay.
Okay. I think enough, Mr. Americus.
I mean that the application artificial intelligence technology can capabilities significantly in the manufacturing sector, like works across various business line and level, or from staffing, planning to product design, and so on.
Okay, sorry, is there a question?
Is that question, Mr. Henricus?
I mean that how to the application at AI in technology enhance the capabilities significantly in the manufacturing sector, like.
Okay. So the thing about AI is that they are able to learn. So you give it a few cycle of observation, feeding it the data, able to learn about your manufacturing operations. From what they have learned, they will be able to maybe if you do it in this way, so that to active.
Okay.
Yeah.
Okay.
Thank you very much.
Thank you.
Yeah, thank you. Okay, we go to the next question from Miss Angelica, Psychology Kemandisan. My question for Mr. Tony is in the context of Industry 4.0, how can industrial engineering leverage insights from psychology to improve productivity and operational efficiency in manufacturing processes and supply chain management? Please provide example of how understanding human behavior and decision-making can lead to better design and implementation of smart factories and intelligent systems.
Okay, I think this is a very interesting question about how you can integrate psychology in industry. You know, in psychology, it's about the human mind. AI is artificial intelligence. So here we are looking at how we can put in human intelligence, human behavior into the machine. I do not have the answer, but I believe end of the day, could be a efficient way of doing things. Yeah. So I'm not too sure, because for psychology itself is also very wide. It can range from behavioral insights to some other deeper area of psychology. Okay, so yeah. So in terms of how it can help to improve productivity, I believe over here, if I were to link it to the human itself, so psychology is about human. How can we use psychology influence the human? Here, I think the psychology part can help to improve the mindset of the people, so that they are more willing to adopt this new technology.
Yes.
Yeah, so that is what I think.
Yes.
More influencing the workforce. Yeah.
Yeah, it will need some research, yeah, to gain some the connectivity between psychology and industrial engineering also.
I think this is good potential for research.
It's a good research. Okay. Okay, I think enough, Miss Angelica, or anything want to ask to Dr. Tony? I think enough, yeah. We can go to the next question from Mr. Henricus Bambang. What are the supporting contributions that should be prepared by the university to make it easier for its human resources to easily enter the industrial world of work 4.0?
Okay, so as I said, Industry 4.0 is really about technology. So it will be really good that people who are trained in human resource understand the words and lingo that people use in area. They to know when when the engineers talk about IoT, they know, okay, I know what IoT is all about. If the engineers talk about AI, okay, I know what the engineers are talking about. Because why is it important? Because when it comes to recruitment, when it comes to selection of candidates,
yes,
they know how to read their resume and identify the relevant stuff for the company. Yeah, so understanding the lingo and what it means is important. Of course, they do not need to know how it works, but understand what the technical terms is all about. I think that's important. Yeah.
Yes. Okay. Next, from Mr. Albertus. Hi, Mr. Tony. In segment of oil and gas industry, as I saw one of the oil and gas service company in JID video, how to implement the 4.0 on it?
Okay. So personally, I'm not from the oil and gas industry, but what I can imagine and think of is oil and gas industry is a very tough environment to work at. Hot, stuffy. It's not a very nice environment. In the past, you really need the human to be there to see to the machine, to operate the machine, to press this button, to press that button, to monitor the gas level, to monitor the combustion level, the percentage, the pollution, and so on. But now with Industry 4.0, the beauty is you can place sensor here and there. So the engineer no need to really climb down to observe. By using a sensor, they can detect the percentage of the gas, they can detect the temperature, humidity, and so on. And all this can be fit into a centralized office. So I believe with Industry 4.0, engineers can probably work in a nice air-conditioned office, but at the same time, they know exactly what is happening inside the machine without them going in on a regular basis. Yeah, so that's what I can think of. Yeah.
Okay. It is enough for the answer, Mr. Albertus?
That's okay. Thank you, Mr. Tony.
Thank you. And we go to the next question from Susanna Arvinda Marida. Okay. Hello, Mr. Tony. Nice to meet you in this webinar. I am Susanna from BINUS University, and I'm currently living in Singapore too. Seeing the growth of more and more industry in Singapore, such as the factories that I saw in the Senoko area and the video in Jurong. Will there be a future collaboration to open factory from Indonesia and Singapore? If so, what about the workers? Is it an opportunity for Indonesian to work in Singapore for the engineer?
Okay. Yeah. Okay, this is $1 billion question. Okay, I'm not from the government, so I don't have detailed insights in terms of which company is going to open the factory here. But what I can say is Singapore is a very open economy. People from throughout over the world, they are here to work. Not an issue. Nationality is not an issue. More importantly is how your skills can contribute to the company. Like, for example, I shared with you 2 days ago, I was at a semiconductor company, Micron. Micron is a manufacturer of the computer chips. They manufacture wafers. So there's a very advanced factory in the northern part of Singapore. So when I was there, the senior director of the factory is an Indonesian. Then when it comes to because we went for a tour inside the factory, then one of the engineer who is sharing with us the simulation, the software, the scheduling of the factory production, he is also an Indonesian. So there is no lack of opportunities for Indonesians. So end of the day is your skill set and your willingness to change environment. Yeah, no problem.
Yes, because President Asia Pacific President from BOS, yeah, Rexroth, basically Indonesian, but now he's moving to German, right?
I believe so.
Indonesian also. Right, so we can go to the next question. From Anna Dangur. How does the era of disruption, such as the emergence of new technology like artificial intelligence or AI, simulation modeling or additive manufacturing impact traditional engineering industry? How are companies in the engineering sector dealing with the challenges and opportunity arising from this disruption? Please.
Okay, so for this question, in terms of how it impact traditional engineering industry, is that if the traditional industry do not adopt this new trend, new technologies, maybe they won't see the impact in the next few years, but down the road, they will see that they will become less competitive because companies that adopt such technology, you can see that their volume will be very high, and yet their costs can be much lower. So in the long term, traditional industry who are still doing it in the traditional way, they might not be able to survive in the long term. Yeah.
Right. Okay, is this enough for the answer? Ms. Anna Dangur? Anything do you want to ask? Okay, I think enough, yeah. The next question from Franz Sinaga. What do you think about the AI will take human jobs on manufacturing because of advancing IoT, AI and robotics that will integrate into one system? How should young generation do, and how far we rely on advancing technology with issues cybersecurity, cloud computing, and so on? Please.
Yeah. So as I shared earlier on, with new technology, certain jobs might become obsolete, right? People are saying that with AI, certain jobs such as a lawyer or accounting, it can be replaced by AI because they can learn and then they can do the same thing. But I believe with every new technology, there will always be new job opportunities being created. Yeah. So be brave. Do not stay away from it because of fear of loss of job, because I think new opportunities will be created. Okay. So end of the day, how do you stay competitive? That's where I mentioned just now, lifelong learning. So always go back to school to pick up new skills, new technologies, which I believe at BINUS, you all have plenty of short courses that are very relevant to the industry and is very up to date. Yeah, so go back to your school and study again. Yeah.
Okay. Is it enough from Franz Sinaga for the answer? Okay, let's go to the last question, if I'm not mistaken, from Agus Saifuddin, asking Mr. Tony Halim, how far AI influence government and how to maximize the potential of AI in governments?
Okay, this is a tough question.
Difficult one.
Tough question. Okay. How far AI influence the government? AI definitely influence the government a lot because, as I said, individually, if as a company, as a business owner, we don't adopt AI, in the long term, you will not survive. Likewise, if a country do not recognize AI and choose to ignore it, the country will not survive in the long term. Because if other countries are embracing AI like crazy, embracing new technologies like crazy, you will be left behind. And that is exactly why, I mean, if you look at China, their technologies is way ahead and advanced compared to many other countries because they are willing to embrace it and move forward. So countries that is not willing to invest, then you will lag behind. But of course, all this involve money. It cannot be just, I mean, the infrastructure is very important. Just I mentioned about the 5G connection, 6G connection, all this has to rely on the government, I believe, to some extent. And so I believe in Indonesia or even many other countries, it's always the case where there is a close collaboration, partnership between government and the private to enhance the infrastructure, to enable the country to move into the AI era. Yeah. So yeah, so the government, I think not to worry, Indonesian government have very good foresight, and some more with the Minister for Education. He himself is from a tech company. I would not worry. He is very creative. Yeah. So the potential of AI, definitely they have discussed. So let them do the job. Okay, let them do the job.
Okay. Now we go to the last question, I believe. This is from Selvella. Good afternoon, Mr. Tony and Mr. Taufik. Thank you for the opportunity. I'm Selvella from Jakarta. I have a question: how to build Industry 4.0 in my general area? And are there any tips for introducing Industry 4.0 to the general public who seems unfamiliar with the development of Industry 4.0? Please.
Yeah, okay. So this one is more for general education, which I think is very interesting because we are living in I 4.0 without knowing it for the general public, right? From the moment you use your cashless payment, your OFO, your Dana, all this is part of the 4.0 because now we are talking about money being moved virtually. Yeah. So we are all living in this 4.0. From the moment you order your Grab, your food, all this is actually 4.0, right? Video on demand, instant 3D printing, all these are also I 4.0. Okay. So in terms of educating the public, it's good to create the awareness, which I believe this is something that maybe as an institution, this can be like there can be a public seminar for the public to share with them what Industry 4.0 is all about. Yeah. So this one I think the institution can play a part in contributing back to the society by having some awareness talk. Yeah.
Okay, I think this is enough for today, Dr. Tony. Thank you for your sharing. Let's have a big applause to the Dr. Tony again. If you have any question to Dr. Tony and the rest, maybe you may directly email to the respective speaker or to the webinar organizer, Industrial Engineering at Semarang. Enjoy the rest of the webinar. Now I will pass to the MC to proceed next agenda. Thank you. Wassalamualaikum warahmatullahi wabarakatuh and have a nice day. Thank you, Dr. Tony.
Thank you so much, Taufik. Moving on to the second webinar session, we invite our second moderator to lead the webinar.
She is Maria Laura Cristia, MSc. Maria Laura Cristia is currently a lecturer specialist at BINUS Online, Bina Nusantara University, located in Jakarta, Indonesia. In 2022, she earned a Master of Science degree in Industrial Engineering from Universitas Gadjah Mada. Her current research interests encompass operation excellence and decision science, vertical and horizontal integrated systems, as well as educational technology. Please welcome Maria Laura Cristia.
Hello, everyone. Thank you for Mr. Nicholas and Mrs. Regina for the introduction. Hello, ladies and gentlemen. Good afternoon, everyone. My name is Maria Laura, and I'm honored to be appointed as the moderator for today's sessions. We still have one more speaker, Mr. Shafruddin. Okay, he is currently employed at Sejong University in Seoul, Korea, working in the Department of Artificial Intelligence since 2022. Prior to this, he worked at Dongguk University for 3 years as an assistant professor and for 5 years as a graduate researcher. With over 9 years of experience, he has focused his research and development efforts in industrial artificial intelligence, industrial analytics, industrial informatics, industrial Internet of Things, and industrial big data. Additionally, he served as an instructor teaching practical courses on programming language, linear algebra, big data, and database systems to undergraduate systems. Okay, without further ado, let's start this session, and the screen is yours. Hello, Mr. Shafuddin. How are you?
Hello, Maria. Yeah, I'm fine. So,
Yeah.
how was the Jakarta? Yeah, right? Are you in Jakarta or
Yeah.
Semarang?
Yeah, I'm in Jakarta right now.
All right, yeah. Nice to meet you, right?
Yeah, thank you, sir. Okay, you may proceed. Thank you.
Okay, thank you. So the talk will be 30 minutes, right? So let me proceed.
I believe so, yes.
Okay. Hello everyone. Good afternoon in Korea, and I think in Indonesia it's still 3 p.m. So here we have a 5 p.m. So let me share my screen and proceed with the presentation. All right. So can you see my screen? Yeah.
Yeah, it's
All right.
okay.
Okay. Yeah. Thank you, Maria, for the opportunity, and thank you for the BINUS faculty for the invitation. And my name is Muhammad Shafrin, and this is a little bit a background of myself. So I did my bachelor degree from Indonesia, more specifically from Yogyakarta. And after that, I got my master and combined PhD in Korea, specifically in industrial and system engineering department. So I think this talk will be also related with industrial and system engineering. And after my graduation, I have a great opportunity to work directly without delay in the same department and in the same university. So after spending 3 years from Dongguk University, I moved to another institution, which is currently I'm working at the AI department, Sejong University. And my research area is related with industrial AI, analytics, informatics, IoT, as well as big data. If you have a similar research interest or project, you might contact me through LinkedIn, or you might also send me email. So without further ado, this will be the content of my presentation. So firstly, we are going to learn what is the IoT, right? So previously you have listened very well and very good speakers from Malaysia as well as from Singapore, Dr. Joshua and Dr. Tony. So they already elaborate many things, right, regarding Industry 4.0. which is one of the challenge is related with Internet of Things. So my talk will not be about the Industry 4.0 or as well as not about the challenge, but it will be more about Internet of Things, which is one of the challenge of Industry 4.0. And we also want to learn the technology trend of IoT as well as the IoT life cycles, and a little bit about a technical term or technical design of IoT architectures. And most importantly, we will share you 2 cases that we have did in the past years, how we can implement IoT system into industry. So the first thing we have did some project in manufacturing, and we also did some project for indoor real-time location system. And lastly, we will give you some concluding remarks, and hopefully you will be able to learn a tiny bit from this talk. Okay, so let's move on to introduction to IoT, or specifically Internet of Things, right? So I think most of you already heard about the IoT and maybe already use in your daily life, right? But let's just watch this very short animation video and try to grasp what is the IoT and why IoT is important and what kind of application that IoT can be used in the real life. So let's just watch this together.
Belakang ada nggak sih? Ngumpet ke belakang.
All right, so from this video, we can summarize that basically IoT is a device, right, that can have many impactful or meaningful impact across industry. So from the illustration video previously, we learned that it impact in the healthcare industry, as well as in building, logistics, transportation, smart city, as well as in retail, right? So first, before we learn into detail what is the IoT and how we can build some application or services into them, it is very important, I think, to know the motivation, right? the impact of this. So by knowing this, hopefully you will have some interest to learn more about the IoT by yourself or with your college in the university. So yeah, the definition of IoT, it is basically a unique device. And this device will have ID or identification or ID. And this device also can be used to communicate, whether communicate through outside world or internally or externally, right? And the things in IoT usually refer to device which have unique ID, as I said before, and can perform remote sensing. If we have a sensor in it, then we can send some data, and then we can send this data through internet or through other form. And also it can be used to monitor and actuating too. So in summary, IoT device can exchange data between internally or externally, and it also can collect data from other devices, and it can process the data internally as well as externally by sending this data to centralized server or cloud server, if you might say. And it also have the ability to perform some local tasks that are assigned for this IoT. As we already seen in the video, in the first example of healthcare, right? We saw that there is an old person wearing some, what you can say, some like a bracelet, or we can say maybe a smartwatch, which has a sensor in it, right? So we can say that this smartwatch is one of the example of IoT device which can sense some sensor. For example, sensing the heart rate, right? So if this old person or old person fell down accidentally, this smartwatch will sense this incident or this movement, and then it can tell or it can send some notification or alert to the medicals or to the family members, so that what you can say, so that the the emergency unit can directly visit the house and give some medical assistance quickly. So those are one of the example of IoT device which have a local test, which sensing the heart rate for the old person, as well as sensing if there is kind of important, if there is kind of a dangerous situation that is currently happening for that old person. Because as you know, in Korea, we have we have a lot of old people recently, and we have a very low birth rate. So in Korea, we develop many IoT technology as well as IoT application and services to cope with this aging country, if you say, yeah. And why IoT is important? If we look at the economical impact, so most of you are from industrial engineering, you might already learn about the economical impact, why this such technology should be embraced or should be adapted, because one of the impact is it will generate a lot of income, or if you might say, it will generate a lot of economic impact, not only for the specific industry, but also for the general people, which is, for example, Indonesian people who are currently working in the industry. If they can adapt this IoT, it will generate a lot of economic value for their company, as well as for the people of Indonesia in more general. And this IoT has been and will be have an impact for many industries, such as it can be used in the electricity industry, insurance, agriculture, if you might say, because most of Indonesia land has very good land for agriculture. If we can adapt this IoT, it will basically improve, or if you might say, it will help the farmer to produce maybe high quality agriculture product, as well as to tackle some of the obstacles that are currently going on with the agriculture industry. And it also has an impact in factory, automobiles. As you might say, we are currently adopting the electric vehicles, right? It can be car or motorcycle. And most importantly, also this IoT can have an impact for the end consumer, the customer that are adopting and they are utilizing these IoT services. In short, yeah, IoT is still a business trend, and this is still emerging technology that we have to learn, and we have to try to adapt, and we have to try to adapt this for our study, if you might say, or for our industry. And there will be a lot of opportunity that are currently going on that if we can understand IoT, and if we can also understand what IoT can be used to solve the current limitation of industry or current what you can say obstacle that are going on in many industry. So yeah, after understanding what is the IoT, basically IoT a device, right? A device. So if you might say that is basically a device, the hardware, or you might say smartwatch or your smartphone. If you can turn your smartphone into IoT device, that also possible. Or you can also use your transportation card. I think in Jakarta, if you are in Jakarta, I think you might use the MRT. And if you want to use the MRT, I think you have to use a smart card, transportation card. And this smart card, or this is transport card, is one of the example of IoT device that you can use for cashless payment for the transportation, as well as to integrate all of the payment of the public transportation through one single public transportation card. So let's learn about the trend of IoT device. So RFID that you have learned from Dr. Joshua is the first speaker. He mentioned that a radio frequency identifier was used to automatically maintain, or it can be used to do inventory for the goods, and it can be used also for monitoring the goods in real time, as well as to prevent any loss that you might have. Because if you imagine, if you work in the big warehouse, or if you work in the big store, for example, if you don't use this RFID tag, this will be many manual work that you have to do, right? If we use this RFID, what we have to do is we just have to turn on the RFID technology and see from the screen, and instantly we can we can do the inventory automatically, because RFID can be detected automatically, and all of the losses can be prevented. Right? And next, move on to the 2010, we have experienced that there are webcam, right? Web camera that we are currently using in front of us. So this webcam has been used for surveillance, for security, for transportation, food safety management, etc. Because basically webcam is also the other device of IoT, or the other example of IoT device, if you might say. And by capturing the image in real time, you can basically develop very impactful and very important applications, such as if you can combine with AI technology or AI, artificial intelligence algorithm, you might also use it for example, crime detection, right? So for example, I'm not quite sure if in Jakarta we have some IP camera or webcam installed in every corner of road, but in Korea itself, we have a huge camera surveillance in every corner of the road, and this surveillance camera can be used to detect such as dangerous situations, such as if whether the crime will be take place, or if there is some you can say emergency situation. Yeah, this camera can detect that things and will send the notification or emergency alert to any parties that are involved in this surveillance, for example. And move on to the next state of IoT technology. We have also technology of IoT device that can locate people and object in real time. So one of the IoT that can be used is that are currently installed in your smartphone is a GPS, right? Global Positioning System, which can detect your accurate location outdoor, right? So without any technical understanding, right? And next, move on to the next. We have also other IoT object or IoT device. As you might see that we have a virtual what is that? Goggle, right? We have a virtual reality as well as metaverse technology that are having this ability to map real world into digital world. In order for us to create such a service and application of mapping physical world into digital world, we have to have some device, right? One of the device that can be used is it called goggle, VR goggle, right? Virtual reality goggle. So this virtual reality goggle is also one of the example of IoT device. So we can map physical world into digital world. And the other thing, if you consider about Industry 4.0, Dr. Joshua from the first speaker mentioned that we have a cyber physical system, right, which is called CPS. So in manufacturing, when we want to map this physical manufacturing device, or you might say machine, right, manufacturing machine into digital world, we have to install some of the IoT sensor in those machines. Why is like that? Because when we want to connect physical world into digital world, we have to have some help from other technology. And one of the technology is called IoT, right? So we have to have that one so that if we can map this physical world into digital world, we can manage this digital world, and directly this digital and physical will be connected in real time. That will be the main purpose of this Industrial 4.0. So now, after understanding those, what is IoT, why IoT is important, as well as the technology trend of the IoT, let's learn about the life cycle of IoT, right? Because in our real life, we have a life cycle, right? We were born, we become baby and child and adult, etc., and old, and eventually die. And in IoT, we have also life cycle. But yeah, this life cycle will be good if we can understand fully. So the first life cycle will be collect, right? So having IoT device, if you might say your smartphone, there will be no impact if we just have it, right? If we just have it without having this first life cycle, which is collect. So the first life cycle of IoT device is to collect data, right? What kind of data? It depends on your IoT device. If we say that you have a smartwatch, right, then your smartwatch will collect a lot of sensor. For example, heart rate sensor, and then it can collect maybe your current status. For example, are you currently sitting on the chair, or are you currently walking, or are you currently exercising, running, something like that, right? Because smartwatch is also one of the example of IoT device. So the first life cycle is collect. And after collecting this data, it is the next life cycle will be communicate. So to communicate, so collecting and communicating this sensor data. And after communicating, we have to analyze, right? Because gathering those data, if you might say heart rate data, there will be also useless, right? Just gathering without analyzing or without doing something about the data, that will be useless. And after analyzing, so in the analyzing process, you might also incorporate other technology or other algorithm, if you might say AI, artificial intelligence, or any business information analytics or visualization, you might say. And after getting the analysis result, the most important thing is action, right? Because as you know, in our previous video, we learned that in the healthcare, when all people wearing this smartwatch, or you might say IoT device, and these all people fell down unconsciously, or for example, and this smart watch sense this heart rate, and the heart rate is like static, then it is very dangerous situation, right? And then this sensor data will be sent to the, or will be communicated through the external or internal, and it will be analyzed, right? And based on the analysis, there will be some action. For example, whether we have to ask the emergency unit directly to visit this all person, all people, or whether we have to send notification to the nearest, what you can say, family members, for example, like that. So the last life cycle will be action or act, right? So this for collecting the data and communicating the data, as well as analyzing and action or acting based on the analysis result will be for IoT life cycle. And now a little bit more about the architecture. So I think most of you are not from technical background, but I hope this just for your information. So basically, based on the life cycle that we have learned, right, we have to have the ability of collecting the data. And then the second thing is communicating the data. And the third thing is analyzing the data, as well as action or acting based on the analysis result. So here on the screen, we have a device connectivity. So this connectivity is related with collecting data and communicating, while in the middle, we have a data processing and analytic. And in the last layer, we have a presentation. So we can present what sensor or what data that we have collect from IoT device, and what kind of action that we have to take in order for us to have a fully IoT life cycle in our real world use cases. And these are some of the open services that we can utilize. So mostly for industrial engineering student, I would suggest that you can find IoT devices that are currently existing in the market. And if you do not understand clearly about the IoT device, you might also want to collaborate with the student from, for example, electrical engineering, if you might say. And if you want to develop the fully connected from the device, from the services, and from the technology, you might also want to collaborate with the student from, for example, computer science or computer engineering, or from informatics, who can help you to develop this fully connected of IoT application and services. So you might be able to integrate it from collecting the data, communicating, analyzing, as well as presenting and doing some action based on the decision result. And let's move on to the IoT application use cases. I think I just want to mention maybe one cases, because I think the time we have just limited time. So the first time will be the IoT in manufacturing. So this is my PhD dissertation. So I did this for almost 3 or 4 years, and we have a big project at the time. So this was from 2017 until 2019. So I did graduate in 2019. So basically, we try to utilize IoT device to monitor the worker in real time. So even though, as you might know, that in Korea we have advanced manufacturing, so some of the part of the product should also be assembly by the human. So not most of the part, not all of the part can be assembly done by machine, but some of the parts should be done by the human. So we have that part. So I think if we can successfully implement Industry 4.0, all of the part can be assembly or can be done by the machine in the future, I think. So here our purpose is we would like to monitor the condition of the worker, whether the worker did the assembly, did the work based on the standard operating procedures, if you might call SOP, right? So usually when we work in the company, or sorry, in the manufacturing, all of the workers should follow the SOP, right? Standard operation procedure. If the SOP is not followed through, there might be chance that the product that has been produced might have a defect, which in result of having many losses, right? Because if the product is defect, then the product should be discarded. So this product couldn't be sold to the end user, and this will be huge cost toward manufacturing. So we would like to monitor each of the steps, and in this case, we try also to implement AI model, artificial model in the analyzing part, so that all of the process, all of this monitoring process can be done in real time and automatically, right? So first, we implement by adapting some of IoT device. In this case, we use Raspberry Pi, and we also incorporate some of the sensor, which is sensed in this case. So as you can see in the picture here, we have okay. So we have illustration that all of the part, in this case, we have manufacturing that produce the door of the car. So if you can see that the door of the car has many parts, right? So depending on which side of the door, it can have a different feature. For example, if it is in the front door of the car, left or right, that might be have a different feature or different part that can be attached to the door slim. So in this case, we have a workstation 1 until 4, and each of the workers should follow SOP differently. And in this case, in our scenario, we gather a lot of data, a lot of sensor data, and also we perform some simulation. What kind of simulation? So first, we did some performance, like following the SOP thoroughly, I mean, nicely based on the SOP. And also we did some anomalies. So we did some action that are not based on the SOP. So for example, we did some, for example, hammering very hard, and eventually the door trim part is broken. And we label those data, we label those sensor data as a abnormal or as a defect, something like that. And we try to simulate this kind of action simultaneously, and we gather a lot of data, and this data later we use it as learning. So we use this as learning for the AI, so that we can have a AI model later on. We use this AI model for monitoring in real time. So these are the sensors that we are using, right? We use the Raspberry Pi, and we use the SenseHead, and how we can and we gather a lot of sensor. One of the sensor that I use is basically temperature. So we want to know the environment of the worker, whether if the temperature is too hot, right? If it is too hot, then it will impact what you can say, it will impact the body of the worker. So maybe the body of the worker will not be in the optimal stage, and this worker might miss the SOP, right? Because the environment is not nice for the worker. And the other sensor related with the action of the worker is accelerometer and gyroscope, because accelerometer and gyroscope can detect the movement as well as the speed. For example, if you see here, if you see the figure here, we have a door trim, right? So the door trim are lie out on the workstation. And me, for example, as a worker, I have to assembly some of the part of the door trim. And if you see from the figure here, we have a hammer. So some of the part should be hammering. So if we did hammering really hard, right, it will break the torch trim. And if we break the torch trim, then this product will be defected, right? Will be defected, then it will be discarded, and the manufacturing company will have a huge losses, right? So this hammering action, as well as what you can say, tightening up the screw, it can be detected by accelerometer sensor as well as gyroscope sensor. Because when we did it very hard, or when we did it not as state in the SOP, then those are recorded and can be sensed by our AI model. And eventually, our managers, factory manager, can receive such as abnormal situation. If the worker did something out of the SOP, then our system can detect it in real time and give some warning system or alert notification to the manager, and eventually the manager can check to the site and give some, for example, give some training, or give some personal training, or checking the site in real time. And I think the second, do I have time, Mr. Maria?
Few more
I think.
minutes.
Sorry.
Around 2 minutes, we can.
Yeah. Okay. Yeah. Okay.
Presentation.
I think so my presentation is too much. I hope it will not overwhelm your understanding for today's webinar. So the second will be, I will just very brief explain. So let's just see the video, and then I will explain this video, and we will close the session today. So basically here we have some video demonstration. On the left side, we have a web UI that can monitor the movement, not the movement, the location of the person in real time. Especially this is in indoor settings, right? So if you know that if you are outdoor setting, I mean, if you are outside the building, you can be located by using GPS, right? Global positioning system that are installed in your smartphone. But if you are in the indoor setting, in the building, it is really hard to know where are you, or if it is hard to know the location of the person in indoor, whether the person is in the first floor, second floor, or whether the person is in the room A, B, C, something like that, right? So this video, we utilize one of the IoT device, which is called Bluetooth Low Energy, BLE. So basically BLE also installed in your smartphone. So BLE is not new technology, so this is old technology, but we can utilize it as a means of knowing, or as you can say, monitoring the person or locating the person in indoor setting. So from this video, we attach this IoT device in every floor and every room, right? So by doing so, because as we know that IoT device has a unique ID, right? Unique identifier, or you might say unique address, or unique ID. So based on this unique ID, we have developed the system. So for example, if I'm in the second floor, I have my mobile phone, smartphone, and this smartphone already installed my application to monitor my location. So if my mobile phone sense this ID, right? If I'm close to this BLE device, which is, for example, this IoT device is in the second floor, then my application in the mobile phone will send through the cloud or to the server that I'm currently in the second floor, because my smartphone sensing this BLE device in the second floor. If I move to the other floor or other room, then I might be able to sense another device. So at that thing, we can accurately, or not accurately actually, we can approximately locate the person in indoor setting. And what is the important of this? What kind of application that we can develop? For example, this also can be used for building security, building management system. For example, in Indonesia, we have a lot of earthquake, right? Or for example, if there is some fire going on in the building, by having this such technology, we can have a effective evacuation, right? Because we know that, for example, in the second floor, we have a 100% by having this technology, right? We can have that kind of ability. So if we know that if in the second floor we have 100 people, then we can allocate the emergency unit to evacuate 100% from second floor, for example. Or if we know that in the top floor we have only 50, then we can allocate, for example, we can bring helicopter, for example, how many helicopter, because we know that only have a 50, maybe one helicopter can take 5%, then we can allocate 10 helicopter to evacuate the person from the top floor quickly. So I think, yeah, that is the presentation for me. And we learn about the IoT, what is the IoT and why IoT is important. And we learn also the life cycle of IoT, because when we want to develop such as application and services based on IoT, we have to have this 4 life cycle. So we have to have the ability to collect, to communicate, to analyze, and finally act, right? And usually IoT can be combined with other technologies such as AI, artificial intelligence, to give more meaningful products and services. I think that's all, Maria, for my presentation. I hope this might benefit for me and for you in general. Thank you very much. Yeah.
Thank you very much, Mr. Shafruddin. Such a valuable knowledge for all of us here. We have several questions in the chat box.
Yeah, sure.
First one, is from Mr. Kumara. Hi, Mr. Shafruddin. Nice to meet you. My question: what things need to be prepared to create IoT services? Also, what IoT-related business are likely to grow rapidly in Indonesia? Maybe you can answer the first question.
All right. So the question was from Miss Maria, right?
Mr. Kumara.
Oh, Mr. Kumara. Sorry.
Mr. Kumara. Yeah.
Okay, Mr. Kumar, nice to meet you. Thank you for the invitation to give a very basic talk about IoT. So what things need to be prepared to create IoT services? Also, what IoT related businesses are likely to grow rapidly in Indonesia? I'm not quite sure because I am not researching the IoT status in Indonesia. But for the general, I think what you have to prepare for the industrial engineering student or faculty, what you have to do is you have to learn what is the IoT in general way, not specifically the device. I mean, not specifically the electronic side of the IoT, right? Because mostly this day you can find ready product. I mean, ready product that you can use to create services. So most importantly, you know how to integrate, right? You have the idea in mind, and you can pinpoint what kind of device that can be used to solve your services. And this, yeah. And other part is like because in this global world, right? It is good idea to have collaborators, right? I mean, working alone with industrial engineering student or a faculty member, it's great, but having collaborator from other domain, for example, from electrical engineering, from economics, or from social science, as already mentioned by Dr. Tony, that we have to collaborate. We have to be able to work with multi or diverse team, right? That will be a great starting point. And related with the services, I think in Indonesia, you have a lot of opportunity, right? So as I mentioned before, that IoT device can be used to tackle some disaster response team, right? For example, how we can detect early earthquake. So that will be really impactful in Indonesia, right? So before earthquake happen, how we can detect it, right? What kind of IoT device or what kind of sensor that we can utilize, and then what kind of AI technology that we can develop, for example, and who will be the response units, emergency unit, and then how we can give how you can broadcast this notification or early warning system, if you might say, to the general public, so that general public can have some time to evacuate themselves. First of all, go to the go to the maybe football field, right? So that they can avoid building, or they can avoid big trees, something like that, and and we can save life, right? Because as you know, Indonesia, we have many earthquake, right? We have many disaster, if you might say. We have, for example, sometimes we can have a flood, sometimes we have earthquake, sometimes we have a volcano. So I think in terms of disaster, you can do that. And in other domain or in other part, for example, if you are from industrial engineering, you might also incorporate this for manufacturing, right? Or for supply chains, or for retails, right? For e-commerce, or for delivery, or what can I say, in the delivery industry, like how you can monitor the goods in real time based on the IoT device. For example, you can attach RFID, or you can attach other IoT device, and this goods can be monitored in real time. I hope that's answer your question, Kumara, Mr. Kumara. Yeah.
Yeah.
Thank you very
Crystal
much.
clear, Mr. Shafin. Thank you.
Yeah. Thank you very much for the next question.
Okay. I would like to ask about regarding the disaster in Indonesia, Mr. Shafuddin.
Sure.
Is there any research about disaster management risk infrastructure in the IoT device, maybe to enhance disaster management strategy there in Korea?
All right. So, yeah. In Korea, we do have such like emergency alert or early warning system that are currently in place, but I have no specific information regarding the device, because my main research team is not related with disaster management or something like that. So apologize for this limited knowledge. But for general point, I mean, if we can collaborate for with the with maybe environmental or environmental engineering or something like that, we might be able maybe to dig or we can also ask for answer from PMKG what kind of device that they have currently in place, right? And how we can connect, for example, how we can utilize this existing device and connect to the computer, or you might say connect to the our developed technology using computer program, and we can analyze. And after that, how we can broadcast, right? How we can broadcast this analysis result to the general public. For example, we can broadcast those through mobile phone. So currently in Korea, if we have such what can you can say, such as if in Korea, if we have anomaly situation, for example, weather, right? So for example, tomorrow we will have a lot of rain, or we might have a strong wind, something like that. Before something happen, we usually receive some mobile notifications. So for example, please take care. Maybe it is predicted that maybe at 2 p.m. today or at 10 p.m. tomorrow, there will be a lot of rain, and it is strictly, or it is advised that you have to avoid, for example, mountain side, right? You shouldn't do hiking, and also you have to avoid the riverside that might be flood because of the the intensity of the rain, right? Because the water will might full the river, and there might be chance that there will be flood because of these parameters. So yeah, we frequently receive this kind of early warning, as I mentioned before, regarding the weather and even also about the earthquake. So I guess in 2018, I was in the 7th floor in the building. Yeah, that was the first earthquake that I experienced in Korea. So Korea is basically very safe. We have no earthquake, but at that time we have sudden earthquake, and before that I received the notification. But yeah, of course the notification very short. I mean, and I didn't check my phone, and suddenly I experienced this movement in the building, and I just checked my phone that oh my god, I received this early warning that there is an earthquake. There will be earthquake in a few moments, and there is some instruction that you should follow the evacuation procedures, such as you have to go to public space. You can go to football space or any open public ground that it is safe for you from any falling object, right? So I think that's all, Maria.
Yeah.
Thank you.
Thank you. Very interesting. Okay, we have another question from Anna Maria. I have question, how has the Internet of Things transformed the way we interact with device and our everyday environment? As the technology increasingly integrated into our lives, what challenge and concerns may arise regarding data security and privacy in the use of IoT? Thank you.
All right. Wow, this is very nice question and difficult one, I think. Yeah, complete question. Thank you, Miss Anna Maria. Nice to meet you. So how the Internet of Things can transform the way we interact with device and our everyday environment, right? So as you know that Industry 4.0, basically it is for manufacturing, right? So we want to transform the businesses, right? We want to transform this physical business into digital business. And your question is basically related with Society 5.0, I think. We want to transform our maybe social life, or if you might say interaction to the digital world. Yeah, of course, it might transform many things, right? As you know, a long time ago, we have no smartphone. I remember in my undergraduate student in 2009, I was my first year in undergraduate. At the time, I have no smartphone actually. So I think, yeah, at that time we just use mobile phone as just calling, voice, as well as texting, right? We do have an internet at the time, but maybe because of my lack resources, I do just have to use that for calling and texting. But now we have a smartphone, right? We can do many things, right? We can purge the internet with really fast. We can call each other in real time. Even though I'm in Korea, you are in Indonesia, we can have this real-time communication. Yeah, that already transformed our life, right? And okay, how we interact, then interaction is depend on us, right? So if we have a smartphone, we can decide whether we want to interact with smartphone all day life, or we can limit ourselves. For example, we just use smartphone maybe in the morning or in the night. Then that is our option to do it, right? But basically, this IoT it will help us, right? It will help our daily life. For example, it will help us to keep informed with our family. For example, if your family are not with you right now, for example, me, my parents are in Indonesia and I'm in Korea, then we can keep in touch through this technology, right? And the second question is about challenge and concern regarding data security and privacy. Yeah, right. So yeah, that's a very high concern related with security and privacy. And challenge, of course, there'll be big challenge. As I mentioned before, that we have learned about device of IoT as well as life cycle. So implementing the life cycle of IoT, there will be a challenge, of course, right? It is not as easy as I said, only 4 life cycles. There might be any obstacle that you will face if you want to implement this IoT. It's depend on the services that you are going to develop. For example, in disaster management that I mentioned, the first challenge might be what device, right? Because my background is not from that disaster management. We have to know, right, what IoT device that we have to incorporate, or what IoT device that we have to develop if there is no such existing device, right? And if we want to develop, how we develop it, right? And who, what collaborator that we can ask to join together and discuss together, brainstorming the idea together, and eventually after we have this IoT device, how we can gather the data, right? How we can communicate the data, and then next, how we can analyze the data, and after analyzing data, how we can act or react based on the decision that we have received, or based on the analysis output that we have from, for example, AI model that we receive, right? Those are a challenge. So in every part of the life cycle, there might be challenge, and this challenge, of course, can be solved or can be tackled by having collaborators, and of course by reviewing some literatures that currently published in the international podium, in international journal or conference. We can refer from them, and we can also try to learn from other experts in this field. And about the security and privacy, of course, when we connect ourselves to the digital world, there might be these two issues. And these two issues are currently also going on, right? We have a smartphone, as you know, and I heard many cases in Indonesia that because of the technology, not because of because of this IoT adoption, many people that are unaware about the security and privacy will be a victim, right? So this will be similar with the IoT, right? Because when we implement this IoT into our businesses, we have to invest also some of the portion of our budget or our time to do some research in security and privacy. As also already explained by Dr. Chenny, that security is number one concerns before adopting Industry 4.0. Why it's like that? Because when we adopt this IoT Industry 4.0, it means that all of the businesses are going to be online, right? Going to be digitalized. And when it is digitalized, right, it means that we have to guard, we have to have, if you can say in Indonesia, is satpam, right? We have to guard these businesses with some security expert and privacy expert, and we have to harden our businesses so that any bad people or any party that want to do bad thing to our businesses will be prevented, right, to do such. So I think, security and privacy will be also another challenge of this IoT in the future and in this stage too. I hope that's answered the question, Miss Maria. Yeah.
Thank you very much, Mr. Shafruddin. I hope it's very clear for Mr. Shafruddin explanation. Maybe one last thing, one last question from Nanda. I would like to ask a question: how prepared is the Indonesian industry in leveraging IoT technology to enhance efficiency and productivity?
Okay. Yeah, very nice question, Mr. Nanda Afrilianto, regarding how prepared is the Indonesian industry in leveraging or maybe adapting IoT technology to improve their businesses or services, right? So apologize that I'm currently have no such knowledge regarding the business or industry status of Indonesia. But in general, as I said in earlier, that there will be a lot of opportunity that you can do in Indonesia, right? because basically as mentioned also by the president that currently Indonesia have making Indonesia 4.0, if I am not mistaken, right? Making Indonesia 4.0, and also Indonesian government want to also having AI, or if you can say kecerdasan artificial, right? So they also have this AI and IoT, AI and IoT in their plan for the 2050, I think, 2045, I think. So for the next few years, yeah, if you can start right now, maybe you can try to fulfill one of the agenda of Indonesian government, which is making Indonesia 4.0, as well as adapting kecerdasan artificial or AI with IoT to enhance the living of Indonesian people, as well as to improve the efficiency of businesses and services in Indonesia. I think, yeah, that will be a lot of chance for you. So as an industrial engineering student, my advice is just learn, as Dr. Tony said, that lifelong learning, right? So you can learn from many things, from many resources that are currently available. You can learn from the internet, you can learn from the live, right? So you can check what kind of IoT services that are currently going on. For example, if you are in Jakarta, you might try to use MRT, right? You have that one transportation card. So that is also one of the example of IoT device that are currently in Indonesia, right? And for cashless, as Dr. Tony said, you can use cashless services like Dana, like other services that are currently going on. And you can also use such car, or what's it called, Grab or Gojek. That's also one of the example of services that adapting IoT, which is they are using GPS to know your location, right? And by knowing your location, they will suggest the nearest driver related according to your current location. That's also one of the example of IoT services. And if you think that by understanding this IoT, and if you think there is some missing services, then you can try to develop your own services or businesses, and hopefully that will be successful and will have a great impact toward your businesses and Indonesian people as a general. Yeah, I hope that's my answer. And thank you.
I hope it answered your question, Ananda Aprilianto. Thank you very much, Mr. Shafruddin, for your valuable knowledge and insights. Unfortunately, because of limited time, we have to end our Q&A session, and maybe Comedy want to proceed with the next agenda. Thank you very much, Mr. Shafruddin, and all participants.
All right, what a great presentation. Before we move on to the thrilling quiz session, let's give a big round of applause to our fantastic speakers and moderators. Their expertise and insights have been truly invaluable in shedding light on the talents of Industry 4.0. Thank you for sharing your knowledge and making this event truly remarkable.
Absolutely. We're immensely grateful to Mr. Muhammad Shafruddin, Mr. Joshua Prakash, and also Mr. Tony Halim for sharing their knowledge and experiences with us. All right, it's time to get the quiz session started. Are you all ready to put your knowledge to the test and compete for some fantastic prizes? If you're ready, don't forget to click on the link in the chat box below.
That's right. Get ready to show off your skills and aim for the top. Here's how it's going to work. We'll present its questions on the screen, and you will have a limited time to submit your answers using Mentimeter. The faster you answer correctly, the more points you'll earn. So think fast as possible and be ready to hit that submit button.
And remember, folks, this is your chance to shine. Keep an eye on the leaderboard to see where you stand among the participants. Will you make it to the top? There's only one way to find out.
But before we kick off the quiz session, make sure to join the quiz link provided so that you can actively participate and submit your answers.
Get those thinking caps on, guys. Each question is an opportunity to showcase your expertise and make your mark.
Best of luck to all of you.
The first question will be IoT lifecycle, accept, collect, communicate, analyze, evaluation, or act. And the answer will be evaluation.
Okay.
Got it right. Wow, on the top of the leaderboard.
We got risky.
And on to the second question.
Okay, let's see. What's the second question?
Where did smart manufacturing first launch? And the choices will be Germany, Japan, USA, Saudi Arabia, or United Kingdom. Which would you choose, Lorenzo?
Probably USA.
Oh, right. Great. On to the third question. And
okay, let's see. In the leaderboard we got.
Wow, still on the top, Riskia.
Not going to the second position. Let's see. What's the third question then?
We've got 198 players going on. From the statement below, which is not the reason why transformation to Industry 4.0. Faster responses.
What do you think is your answer?
Which would be the answer? And
Let's see.
The answer is knowledge, and 16 players got it right. Still on the top, Briskia, followed by William Harley and Natania Kezia. There's two questions left, sorry.
Is a single board computer flexible, low-cost platforms to which different devices may be connected, open and well documented? Its answers you will pick. Regina.
Probably Python? Oh, wrong. Sorry.
All right. Let's see. Who got the first position right now? Wow. Is still holding the first place.
Followed by Chafiala and Joshua.
Yep.
On to the last question.
For the last question.
Will Riskia still be in the lead?
Let's see. In Singapore, where is the district that assesses leading industry 4.0 hub located? What do you think is the answer, Regina?
Jurong?
We'll see.
No.
Nice one.
Still holding on the first place.
Okay, and that concludes our exhilarating quiz session. We hope you enjoyed the challenge and put your knowledge to the test. Now it's time to announce our top 3 winners who showcase exceptional expertise in Industry 4.0.
In first place with an impressive performance, we have Ruskia. Congratulations on your remarkable achievement.
All right, so who is the second place winner? Okay. So moving on to our second place winner, let's give a round of applause to Joshua. Well done.
And finally, it's time to announce our third place winner, the participant. Congratulations to Michael. A big round of applause for all the winners.
Yep, a big round of applause to all our winners and participants for their remarkable efforts and enthusiasm. For all the winners, kindly please share your e-money number and contact our committee to get the prizes.
Thank you all, the participants who took part in the quiz. Your active engagement and enthusiasm made this quiz session even more exciting.
Keep up the great work, everyone. We hope this quiz has ignited your curiosity and motivated you to continue exploring the fascinating world of Industry 4.0.
As we reach the end of this incredible event, we want you all to capture this memorable moment.
That's right. So we invite all participants to turn on your cameras and get ready to share a smile.
To the media committee, Sena, are you ready to take documentation for this event?
Okay, before the documentation session start, it would be great if every participant turn on the cameras first. Kepada seluruh peserta, mari on cam terlebih dahulu.
Alright, so turn on your camera, guys.
Okay, let's start. The first slide, please get ready. 1, 2, 3. Second slide, 1, 2, 3. Third slide, 1, 2, 3. Fourth slide, 1, 2, 3. Fifth slide, 1, 2, 3. Sixth slide, 1, 2, 3. Seventh slide, 1, 2, 3. Eighth slide, 1, 2, 3. Ninth slide, 1, 2, 3. 10th slide, 1, 2, 3. 11th slide, 1, 2, 3. 12th slide, 1, 2, 3. 13th slide, 1, 2, 3. 14th slide, 1, 2, 3. 15th slide, 1, 2, 3. 16th slide, 1, 2, 3. And the last slide, the 17th slide, 1, 2, and 3. Thank you so much.
Now we have reached the end of this incredible event, and we would like to express our deepest gratitude to each and every one of you. Thank you for joining us today and actively participating in this enlightening international webinar on Industry 4.0 challenges.
And by the way, we have an important announcement regarding the certificates. To receive your well-deserved certificate of participation, we kindly request all participants to fill out the survey that will be provided soon in the chat box.
That's right. We appreciate your understanding and cooperation in this matter.
Thank you in advance for your participation today. We greatly appreciate your support and look forward to delivering even more impactful events in the future.
Farewell, everyone. Remember, your feedback matters and your certificate awaits. Goodbye and take care, everyone.
Once again, thank you all for joining us on this incredible journey. Until we meet again, stay bold, stay innovative, and keep shaping the future. See you.
Thank you, Regina and Nicholas. Thank you.
Thank you, Regina dan Lorenzo.
Oke, thank you, Kak.
Nice catch, mate. I hit the ground running. Now look what I am becoming. Greetings, agents. I am Blackspot. Welcome to the Danger Dome.
Make the leap.
Oke, terima kasih Regina, Lorenzo yang sudah bersedia menjadi MC terus teman-teman panitia juga, dan para pembicara mungkin masih ada. Thank you for your knowledge, Mr. Syafruddin. Moderator juga. Oke, thank you all, and thank you semuanya. Terima kasih. Selamat sore semuanya. Thank you.
Thank you, Bang.
Masih juga Pak.